Welcome back to CSEC Math Prep. So far in our series, we have covered computation number theory, algebra, geometry and trigonometry, functions, and today we're going to be covering statistics. Now, without wasting any time, some of the concepts we're going to be covering are what we should expect in any of the CSEC exams on statistics: mean, mode, median, range, probability quartiles, frequency table. In terms of representations, frequency table, bar graph, line graph, or frequency polygon, pie chart, histogram, and cumulative curve. Now, in any given year, at that question there, right, CSEC will normally give two or probably just test completely on one of these representations here. However, the other concepts like mean, mode, median, range, and so on, they are always wrapped up in the questioning from any one of these representations, right? So then, without further ado, our intention, of course, is to cover 5 questions and to see how each is being tested. Now, there are 6 representations here, but I'm doing 5. Therefore, I'm going to have to probably double up. I think for the frequency table and the bar graph, we'll be doing them in one. Let's go. Now, we have a question here that says a class of 30 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. So, for example, the 5 here among our list means that this student had 5 books in their bags, so on and so forth. We're asked to copy and complete the frequency table for the data that is shown. Now, looking at the data, right, we are noticing that for person with 1 book, there are only 2 students. For 2 books in their bags, there are only 3 students. But there are 5 students here with 3 books in their bags. And there are 6 students here with 4 books, so on and so forth. And there are 3 students with 7 books in their bags. Completing that section there, we'll have our frequency completed. Now, you are in exam and you have completed your frequency. Always count that column there to ensure that it's the same as the number of students in the survey. If that is so, then this is correct in terms of you selecting these numbers in their places. The table also has a tally section here. I haven't completed that one here, but if you know how tally works, for example, there are 6 students here that have 4 books in their bags. It will be 1, 2, 3, 4 strokes. And then for 5, you cross that, right? And then add another one to make 6. In any case, let us continue. The 5 students here that have 3 books in their bags, right? If you multiply 5 by the 3, we end up with 15. In total, there are 15 books in these 5 students' bag. And if we multiply across as continue, we would have the FX column here being completed. 6 4 is 24 and 7 3 is 21. And these would be the number of books, right? So the completing the copy and the completing the table here, 4 marks. All right, that's the same table here. We're on the same question. Part B of the question said, state the modal number of books in the bag of the sample of the students. Now, mode means the one that is occurring the most in terms of frequency. From looking at the data here, we see that 7. It's a common mistake to think that 7 is the mode, but no, 7 is only an indicator as to what number here is the mode. So the mode here is 5. Even if we were looking at the raw data, 5 is the number that occurs the most. 1 mark. Now for part C of the question, using the table or otherwise, calculate the number of books. Right? The total number of books. Now remember, the FX column is what is telling us the total here, right? So when you add that column, the result is 127. That's the number of books in all the bags, right? For the 30 students, 2 marks. And then in following, of course, subsequent question says the mean number of books per bag. So let's not forget that mode is the number that occurs the most, and mean, the same thing we call average, even though all three types are measures of averages, is when you divide, right, the total by the number of the frequency. The answer is 4 here. Now, for this video, I don't have here the formula for finding mean, but the information from a frequency table, the mean x is normally equal to the summation of fx column divided by the summation of f column, right? So 127 divided by 30. And that would be the notation. All right. So 2 marks for the mean there. And then determine the probability that a student chosen at random has less than 4 books in his or her bag. Now, the definition for probability is really the measure of chance that an event will or will not or may not happen, right? It's given as expected outcome over the total possible outcomes. And looking at our table, these persons here, they have less than 4 books in their bags, right? We have 5 persons with only 3 books. We have 3 persons with only 2 books, and then we have 2 persons with 1 book in his or her bag. So that is 10 persons out of the 30. And that's our probability. 10 out of 30, or 1/3. For those who want to give the answer in decimal, it would be 0.3. 2 marks, and that completes the 11. Now, as I said, this is what statistics question is like. You are given the frequency table. Sometimes you are given the frequency table and you're asked to represent the information on a bar graph. There have been times when CSEC give you a bar graph and they ask you to extract the information from it to draw the frequency table. But with the same table, right, we are going to be representing the information here on a bar graph. So we have the number of books here to the left. And if you notice, the X here in this column will represent that on our X-axis down here. 2 notable things that we should remember is that the bars, when doing a bar graph, should be equal distant apart. And also the size of each bar should be the same. They shouldn't vary in size. All right, so a number of persons with 3 books in their bags, 5, 4 books in their bags, 6, so on and so forth. And our bar graph would look like this. And only 3 persons in the end there with 7 books in their bags. Very easy representation. It's a frequency table. If we're asked to represent on the bar graph, here we go. And that completes that. All right, onward to another question on statistics. A class of 32 students participated in running a 400-meter race in preparation for their sports day. The time in seconds taken by each student is recorded below. All right, in our table here, we recognize that there are 3 of the rows that are already completed. We have another 4 rows to complete here. I want to point out that 50 to 54 here, this kind of information, we call it grouped data. Sometimes based on the numbers or how many of the numbers representing in the frequency table, you probably want to group the numbers sometimes. So this is one such case. And we have 3 numbers here falling into the other category, 65, the other class, 65 to 69, 70 to 74, we have 7. We have another 4 between 75 to 79 seconds for the 400-meter race. And for 8 to 84, we have 5. Now, if you complete this table, you would have gain another 2 mark here from table just by looking at information and extracting the things that we need. All right, part B of the question said using the raw scores, right? Determine the range for the data. Range is basically a measure of spread, and what's happening there is the highest value, 83, as it is recorded here, minus 51, the lowest score. So the measure of spread here is 32. That's what the range is for 2 marks. All right, there are other questions here on the same. Well, let's complete our table here as it was. And then the question, using a scale of 2 centimeters to represent 5 seconds on the horizontal axis, and a scale of 1 centimeter to represent 1 student on the vertical axis, draw a frequency polygon. So from this frequency table, they want us to construct a frequency polygon, the same thing that we call line graph sometimes if we use the word interchangeably. And we need to make note of that line after. An empty interval must be shown at each end of the distribution and the polygon closed. So 6 marks for all that. And let's go. So labeling our axis, 1 centimeter represent 1 student, right, for the frequency. And along our x-axis, we need an empty interval at the beginning and at the end, as the question is requesting. All right, one of the reasons for that is that when we are working with group data like this, 50 to 54, 55 to 59, so on and so forth, we're going to be plotting the points mid-range as we have them. So for example, for those who run the race between 50 to 54 seconds, the frequency 3, right? We're going to put the point in between 55 and 50 there, because there are 5 centimeters representing that category. So we'll just put these frequencies in their respective places in between the categories, right? And then we connect them using lines like this. And of course, it's requested that you close your representation here, right? At the extra empty, right? Interval there. Now, if it was just a line graph, then it wouldn't have been a requirement for you to close the bars, close the representation. But since it's a frequency polygon, then yes, it should be closed. And that would be our representation of the times the students took to run that 400-meter race. There's another question here, part D. To qualify for finals, a student must complete the race in less than 60 seconds. What is the probability that a student chosen at random will qualify for finals? Right, now, we know that probability is expected outcome over total possible outcomes already, but how many students here from the table that you're seeing actually ran the race in less than 60 seconds? We have them right here. There are 3 students who ran up to 54 seconds. And then we have 4 students between 55 to 59 seconds. Those are less than 60. So the expected outcome is 7, and there are 32 students in the representation here in the survey. So probability is 7 over 32 for another 2 marks. And guess what? That's the end of another statistic question featuring the frequency polygon. All right, very good. You're going so far. All right, so another one. A class of 24 students threw a cricket ball at sports. The distance thrown by each student was measured to the nearest meter. The results are shown below. Another example of a frequency table with grouped data. I'm just looking at information. We're going to be representing. I was filling out this table the same way we did the last 2. So so they're asking us actually to fill in the rest of the table, starting not only with the frequency, but the other classes. 22, 29, 30, 39. So the next one will be 42, 49. And there are 8 representing in that category. And there are 4 more representing 50 to 59 category. That's what, 6 of them. And then we have 60 to 69, 2, and 3 marks if we got that correct. As I said, it's good for us to always double check by adding the frequency column to ensure that's the same as the number that they say that's in the survey. 3 plus 5 is 8 plus 8 is 16. 16 plus 6, that's 22 plus 2, that's 24. Okay, so we are on par. All right, now, part B of this question here is a state the lower boundary for the class interval 20 to 29. So that is our first class. Now, this year, 20 to 29, our first class, the numbers that you're seeing, 20 to 29, they're called class limits. So this is the upper limit and 29 is the 20 is the lower limit and 29 is the upper limit, but they're asking us for the class boundary. Now for this, class boundary is just midpoint between the classes. So if you notice, class 1 end at 29, the other class begin at 30. If we should add 29 and 30 and divide by 2, we get 29.5. In other words, adding 29.5, 0.5 to 29 would give us our class boundary. What it would mean is that if we take 0.5 from 20, it will give us our lower class boundary, which would be 19.5 in that case. So adding 0.5 to the upper limit and taking 0.5 from the lower limit is what would give us our boundaries for each class. But they're asking here only for the boundary for the first class, 20 to 29, which is 19.5. Boundaries will come very important to us as we go along. So let's not forget that. All right, 1 mark for that. All right, now continuing with the same question here, using a scale of 1 centimeter on the x-axis to represent 5 meters and a scale of 1 centimeter on the y-axis to represent 1 student. Draw a histogram this time to illustrate the data. 5 marks for this histogram. So first, on our vertical axis, 1 centimeter represent 1 student. But on the x-axis now, they want us to use 1 centimeter represent 5 meters. Now, if we look back at our frequency table here, right? Do you remember? 19.5 is our lower boundary and 29.5 is our upper boundary for the first class. For the subsequent classes, right? We're going to have 39.5, 49.5, 59.5, and 69.5. Now, the thing about the histogram, if you are comparing with the bar graph, is that the bars on the histogram, they are joined together. That is why we need a class boundary for a common point for those bars. So if you notice, 29.5 is the upper boundary for the first class. It is also the lower boundary for the second class. Because if you take 0.5 from this, from 30, you're gonna have 29.5. And as such, we will label starting with the lower boundary, right? 19.5 here, 29.5 there. Now, it seems as if we're going contrary to what the information was saying. They say 1 centimeter represent 5 seconds. But what we're having is 2 centimeters representing 10 seconds, but it's the same thing. All right. Now, it may look complicated, but only if you just focus and recognize that all the upper limits here are represented down here. The only lower limit shown is the first one here, the 19.5. The moment we label starting with that, then our histogram can be plotted. And because 29.5 is the same for, it's a common point for the lower limit and the second class here, 29 and the 30 here, then the other bar featuring the 5 persons would go right beside. And as such, the other 8 persons that threw the ball 40 to 49 would go right there, and 59 to 69 for the other 2 persons. And that is our histogram, right? Simple representation. All right, there are 2 more questions here. We have 2 more marks here to get. The number of students who threw the ball at distance recorded 50 meters or more. 50 meters or more. Now, if we look on this table here, right? 6 persons threw the ball between 50 and 59 meters, and another 2 persons. Oh, wait, they are above 50 by far. 60 and 69. So the number of students who threw the ball 50 meters or more is 8, right? Good. Now, the other question is asking the probability that the student, right, threw the ball, that selecting a student randomly would have thrown the balls 50 meters or more. Since we know the number of them, it's expected outcome or total possible outcomes. And CSEC was really helping us with the answer for that one. They seem to love this fraction, by the way, 1/3. 8 over 24 is the same thing as a third. So that's the probability of selecting a student who threw the ball 50 meters or more. So the bar graph, the frequency table, the histogram. All right, we're going well. We just have 2 more representations to go, and we are good for statistics. All right, so let's look at this one. The table below shows the ages to the nearest year of persons who visited the clinic during a particular week. We have the ages given, grouped data again, number of persons, but then we have a third column now that is saying cumulative frequency. Now, basically, the cumulative frequency is frequency that adds as we go along. So, for example, the lowest in terms of age of the person who visited the clinic is 40 to 49 years, right? There are only 4 persons, but cumulative, well, let's go to the second category here. 50 to 59 years. The person who visited the clinic was 11. So for the first class, only 4 persons. For the second class, 11 persons. But cumulatively, it is the 4 plus the 11. So it's 15 persons that visited the clinic between the ages of 40, not and 49 now, between the ages of 40 and 59. So the 11 persons from this class is being added to the 4 persons from the previous class, giving us the 15. And if you watch the trend, it will be the 15 plus the 20 from the other class that gives us the 35 there. And the 35 to the other class will give us the 47 there cumulatively. And the 47 plus the persons from the other class will give us the 50. And there are 50 persons in the survey, right? So we have all the cumulative and the categories that they belong to in terms of, if you look at the number of persons here, that completes the table and give us our first 2 marks out of 11 for this question. Now, part B says using a scale 2 centimeters to represent 10 years on the x-axis and 1 centimeter to represent 5 persons on the y-axis. Draw the cumulative frequency curve for the data. All right. So let's look at this. 2 centimeters represent 10 years on the x-axis, 1 to represent 5 on the y-axis. All right, so if we're labeling our y-axis with the cumulative frequency, is 5, 10, 15, 20, so on and so forth. 1 centimeter to represent 5. And then for our horizontal axis, remember with the histogram, we're using the boundaries. For the cumulative frequency, we don't have to. But since we have used the boundaries for the histogram, let's just continue suit, right? So 40 is the lower boundary, the lower limit for that first class. So the lower boundary is 39.5. Apart from that, we're using all the other upper boundaries. 49.5, 59.5, 69.5, 79, and 89.5. And in plotting our information here now, we're not going to plot this column of persons. What we're going to be plotting is the cumulative frequency. Right? So putting in our x-axis labeling there, horizontal axis, and we're starting with our lower boundary 39.5. All right, so we're gonna have 4. Up to 49.5, we have 4 persons, right? That visited the clinic. And then cumulatively, 4 plus 11, we have 15 persons up to 59 years. And then continue with the information 35. If you're plotting, by the way, and you recognize that your graph is coming downwards, it probably means that you're plotting the frequency instead of the cumulative frequency. Because there's something special about the cumulative frequency. It never goes down. Right? So we are at that 35 mark for the up to 69 years cumulatively. And then we have 47. And for all the persons who visited the clinic up to 89 years, we have 50 persons in the survey. Plot all those points at the upper bounds. Then we have our cumulative curve. A neat, nice curve like that, looking like a snake. All right, so that's it for our cumulative curve. And let's focus just now on the other questions that are being asked here. So use your graph drawn, right, to estimate one, the median age for the data. Now, we have done questions that speak to mean, right, and also to mode, right, but median, we can't escape. Now, for the cumulative curve, because the curve is showing information that has already been organized, right? The curve can tell the median just by splitting the information in two. So the number of persons involved in this survey is 50. Half of 50 is 25. On our cumulative frequency column here, we have 25 right here. So we'll go across until we are at the curve. So from 25, go across until at the curve and then come down and then read the information that is right down here. And that's the median. So the idea is to do what? Find half of the data, which is 25, draw dotted lines until you are at the curve, and then read the information that's at the bottom there. Because we have some 0.5 business going on down there, it may seem hard to read, but it is 64.5 years. If it is that this year is 59.5, 60, 61, 62, 63.5, then 64.5. To show you that it's in the right place. If we should continue without 65.5, 66.5, 67.5, 68.5, and then over 69.5, since we're using the boundaries. So the median age is 64.5 years for the person visiting the clinic. Good. Then we have the probability that a person who visited the clinic was 75 years or younger. By the way, let me just make note to what's happening at the last line here. Draw lines on your graph to show how these estimates were obtained. Also, depending on how you draw your graph, you may not get 64.5, but the question here is telling us how these estimates, which mean it may not be exact, but it shouldn't be too far off, right? So the probability that a person who visited the clinic was 75 years or younger. Also, the thing about drawing lines is that they should stay, so don't rub them out. Let them stay to show the estimates were obtained. All right, so the question again was, the probability that a person who visited the clinic was 75 years or younger. All right, now 75. So when we're finding the median, you start with the cumulative and then you came across and read down. But the years are at the bottom here. Now this is an error. Where is it time in seconds? It should be years down here, right? What happened is that I copied it from the previous, but we're doing the information with the histogram. Forgive me for that. All right, so years should be down here. So where would we find 75 years though? We have 69.5 here, right? And if we should continue, we would have 60, 70.5, 71, 72, 73, 74.5, and then the other note here is 75.5. But we need what? 75. So all we do is come back one place here, whoops, right in the middle there, and that would be our 75. It's not hard to find, right? And we'll continue way up to the curve and then come across here and read, right? So it's 40, 41, 42, 43, it seems to me. So it's 43 years. So the median is 65 years and 43 years for those who visit the clinic. 75. Hold on there. It's not 43. Oh man. So this is not 43 years. This is 43, right? But this is frequency. So 43 persons, not years. My bad. So the probability then is not 43 years, it's 43 persons. And because we're talking about expected out of over 2 possible outcomes, it will be 43 over the 50. 43 out of the 50, right? And we would have gotten our 2 marks here. So forgive me for this. What type of a mistake is that? And that's what our cumulative frequency is like. Now, you would notice, I think in almost all the questions, the concept of probability was right through. So remember, the definition for probability is expected outcome over total possible outcomes, right? So it'll be 43 over 50. Most of the persons, right, that visited the clinic was 75 years or younger, not more than that. All right, so very good. And we're off to another representation, which is our final one, right? All right, so let's watch this one keenly. At a career guidance seminar, a survey was done to find out the type of careers that Form 5 students were likely to choose. The results are shown in the table below. And then we have the list of careers there, lawyer, teacher, doctor, so on. Number of students that prefer those. Now, the first question, there are 1,080 students in the survey. That's important information, right? And part A now is saying, calculate the value of T, the number of students who were interested in becoming doctors. Now that's missing from our table there, but the 240 students wants to become lawyer, teacher, artist, salesperson. That number would amount to 975, but there are 1,080 students there. The difference would tell us the number of doctors there are for 2 marks, right? Good. All right, so we know that's 105 doctors, and if you add all those, you would end up with the 1,080 students. Now, the rest of the questions, let me go back and look. So let's look at this. The data above are to be represented on a pie chart. calculate the size of the angle in each sector of the pie chart, right? And then below that, they're saying that we should use the radius of 4 centimeters to construct the pie chart. That's a whole 8 marks. That's a lot, right? All right, so let's do some calculation and then we draw our pie chart for the 8 marks, 2 marks for the 105 doctors right there. Good. So let's go. Pie chart is nothing new to us. It is one of the most popular representations that we can remember off the top of our heads, right? It's a very unique representation. The number of students who want to become lawyers is 240 as a fraction of the total. But if we want to find the angle measurement, it's a very tempting thing to multiply by 100, but that's when you want to find the percent. But we want to find angle measurement, so it's multiplied by 360 degrees. In calculating, we recognize that the answer is 80 degrees. You can grab a calculator and ensure that that is correct. So that's for the lawyers, and 189 for the teachers times 360 again would give us 63 degrees, so on and so forth. Now the same procedure would work for the doctors, artists, and salesperson, and that is 35, 72, 110. So let's put these numbers up here over the total and multiply by 360. That would give us our 4 marks, right? Just to calculate the angle sectors, right? Sector angles. Now, they said this line should be 4 centimeters. So what you do is you'd open your compass to 4 centimeters, right? And then draw your circle. After having that, you use this radius as your reference point. Now, for the lawyers, the 80 degrees, you just simply take the protractor, ensure that that line that you draw there, right, is in line with the baseline on the protractor, and you start reading from the 0 at this end. So we need 80 degrees, 10, 20, 35, 50, 60, 70, 80 right here. And then you just draw 80 degrees for the lawyers, right? Now you'd have a new reference point, which is a new line. And you put your protractor there, ensuring that the 0 is in line with that line. And you count another 63 degrees. And you draw a line. 63 degrees to represent the teachers. A new reference point again, right? And that's now measuring 35 degrees. 35 degrees to represent the doctors. And then new reference point, 72 degrees to represent the artist. Doctor's measurements are missing here, right? So it should be 35. And then, of course, the rest of it would be 110 by default. And that would complete our pie chart, right? Naturally, you're in exam, please ensure that you label these little sectors here with the different representations there. And that is it for this pie chart question. A full 10 marks. Congratulations. You can look through when you do have the time to all different representations if you know you're weak at one. If you, however, continue to browse through other past paper questions, you will recognize that each of them will have one or two of these representations that they're testing on any one of the exams. So you are good to go, really, based on this video alone, when it comes to statistics and moving on to the next measurement. Thanks for being here. I'll see you in the next video.